With a 5-micron insert, and it.
A rat lungworm awareness forum was held at the Pahoa Community Center this Sunday, and the topic drew a large crowd of concerned residents. Dr. Susan Jarvie with Daniel K. Inouye College of Pharmacy, a leading scientist studying the disease, made a presentation to the crowd. Jarvie went over several important studies that she and the college hope to get done in the near future that will hopefully increase our understanding of the disease and help fight it.
We want to conduct studies to find out where the rat lungworm hotspots are on the island, and if we can do that, then we can target those areas for concentrated rat and slug control. We want to be able to determine what solutions people ask us all the time. What should we wash our veggies in? We want to be able to do that study, a comprehensive study. We want to evaluate the possibility of rat lungworm transmission in water. Kay's done some interesting studies in the last 6 months. We want to determine if rat lungworm DNA can be detected in the blood. They know it can be detected in the cerebral spinal fluid, but who wants to have a spinal tap, right? And so if we could get an assay up and running so we can detect the parasite DNA in the blood, which would be a kind of a hit or miss. It's not a blood-borne parasite. I also worked with a fellow from Spain who developed a vaccine, and we tested this vaccine in wild Hawaiian rats, and I'll talk a little bit about that. And then we're currently conducting a pilot study to determine the prevalence of human rat lungworm infection in East Hawaii, and I'll talk a little bit about that. So for the hotspot, find out where the hotspots are, we developed a molecular test, and a molecular test is a test that allows us to detect parasite DNA. And so we developed this test so we can estimate the amount of larva DNA in a slug or a snail, and then go back to determine approximately how many larvae are in that slug or snail. And we're kind of in the middle of this study. We've tested quite a few, and there's a map at this website, and this website should be on the brochure, and it should be on the little insert that's in the books. You can go there and you'll see a Google map, something like this, and you can click on any one of these pins, right-click on them, and it'll tell you how many we tested from that area and if they were positive or negative. So you can go to this website and find that. And so Rob Hollingsworth, back in 2007, he collected from the Puna area in 2005, and of his data showed that about 77% of the semi-slugs that he tested were positive, and only about 24% of the Cuban slugs were positive. Remember, this is a semi-slug that is really the nasty one, and this is the Cuban. Now, we're about 7 or 8 years later now, our lab has looked as well, and again, 77% of the semi-slugs are positive, remaining consistent 8 years later, but none of the Cubans were positive that we tested. So it looks like there's some sort of a host shift going on that really needs a little bit more attention. And again, this study is just midstream. We ran out of money, so until we get additional funding, that's where that stays. How various solutions are, how effective they are at killing, and I use the term killing loosely. What we're doing is looking under the microscope. So we isolate larvae from slugs, and then we put them in different solutions and see how long it takes for them to stop moving. So it's an immobilization. In order to do this correctly, we have to develop a death assay, and actually we're working on it, some metabolic test that we can use that'll say these larvae are really dead, and even if you put them back into rats, they wouldn't cause disease. And so actually my daughter, who's a senior in high school at Hilo High, is working on that. But what we're looking at here are different solutions and their effect on mobility. And so after 20 minutes or so, and we record over time, how effective are these solutions at causing the worms that wiggle, and to just stop and curl up. And at least they look like they're dead. And so all these lines up here, so this is over time and percent mortality. And so all these lines up here indicate they're quite effective within 20 minutes. And all of these are either bleach or salt. Okay? Distilled water was not effective. 3% hydrogen peroxide was not effective. Vinegar was not effective. Remember, these guys can live in our stomach. Our stomach acid is like pH 2, right? And that's about what vinegar is. So they love acids, okay? We've tried all of these guys, neem oil, MMS, peppermint oil. None of them are effective in killing the larva. And again, this study, we haven't tested all the veggie washes we should test. And again, it's kind of halted until we can get some additional money. And again, we're recommending the use of a slug jug to kill the slugs and the larvae. And these little yellow dots are all the sites that they've tested. The ones that are red came up positive. So for Angiostrongylus cantonensis. So rat lungworm is throughout the state, except Lanai. They just didn't happen to find any on Lanai in this particular study. So if you look at those sites, on Kauai, 34% of them came up positive for rat lungworm. On Hawaii, 33%. So you have to ask, why are all the cases coming from the Big Island? Why are they mostly coming from the Puna east side of the Big Island? The semi-slug is only documented on Oahu and Hawaii. It's not on Kauai, so that might play a role. And also catchment use on Hawaii versus Kauai. Catchment use here is much greater than on Kauai. And if you look at the maps, here's Puna District, 75% of the households are without municipal water, and Ka'u 43%. So there's a huge number of people that are on catchment or well water here. And some victims we've talked to believe they were infected via catchment water, including Smiley's son Phoenix. And you know, there's a big difference in how catchment tanks are maintained, and that's really important. We worked with USDA APHIS. They have their facility in Hilo, and we we needed uninfected rats, so we captured live rats on the island, mated them, produced uninfected progeny, and ran two studies in the last couple of years. One of them was a pilot study to determine if rat lungworm DNA can be detected in blood of a rat. Okay, this goes back to diagnostics. Can we use human blood and do the same thing? You know, test for the presence of a parasite in human blood. And so the long and the short of it is that we could detect rat lungworm DNA in the circulating blood of a rat through a period of infection. So if we can do that, and that paper was just published in PLOS 1, if we could do that in rats, then I think it's worth trying it in humans. The other one was a vaccine trial, so working with Antonio Osuda from Spain, he developed a vaccine, has it patented in I think 17 countries, and has worked in a number of different systems, but not rats and not Hawaii Angiostrongylus cantonensis. And so we tested this vaccine. We had a group of 20 rats that we vaccinated, 20 that were not vaccinated, then challenged them all with live larvae, and unfortunately they all developed adult worms in their hearts and lungs. So the vaccine was not effective enough against the Angiostrongylus here to be able to inhibit rat lungworm development in the rats. And so we're following up with some immunology studies to see if it did anything, if the vaccine worked at all.